Hey guys, I'm back with another fancy video. 1.5, exploring angle pairs. Woohoo! Here we go. Alright, lots of stuff that we need to cover. The first thing I want to talk about is adjacent angles. So, there are two coplanar angles with a common side, a common vertex, and no common interior points. What exactly does that mean? Alright, so let's look at these diagrams of some angles. Right here, they're on the same plane. They have a common side, this ray right here, and a common vertex. See how both of their angles come from the same kind of little area? So we could say that these are adjacent angles. All right, angle 1 and angle 2 are adjacent angles. If we look over it here, I'm talking about angle 1 and angle 3. Here's angle 1 and here's angle 3. Notice they don't have a common side. So because they don't have a common side, they're not touching, they are not adjacent angles. You need to look back over here at angle 1 and 2, see how they're touching with this common side, and those would be adjacent angles. Moving along, we're going to talk about vertical angles. Vertical angles I like to call kissing angles. And they have sides that are opposite rays, and their angle measures are always congruent, meaning their angles are always going to be the same measure. Sometimes people have a hard time recognizing vertical angles, but hopefully we can get that remedied. So here is my diagram of these vertical angles here. All right here, angle 1 and angle 3, it's in green. It might be a little hard to see. Those are vertical angles, and I say that they're kissing because right here and right here where the angles are, it's almost like two bird beaks, and they're two little bird beaks kissing. So angle 1 and angle 3 are vertical angles, and therefore, my 3 dots for therefore are congruent. Angle 2 and angle 4 are also vertical angles. They're directly across from each other, and their angles are kissing. They are congruent as well. Those are vertical angles. Moving along, we'll talk about complementary angles, which you might be pretty darn familiar with. Complementary, when you hear the word complementary, you need to think of 90 degrees. It's two angles whose measures have a sum of 90 degrees. Remember, sum is adding when you add them together. Each angle is called the complement of the other. So right here we look down at angle 1 and 2. We don't know their measure, but we know this is a right angle because of this square right here, that it's 90 degrees. So we know that whatever 1 and 2 are, when we add them together, we get 90 degrees. Well, over here we have angle C and angle D. They're not touching. They don't need to be touching just to be complementary. But when you add 47 and 43, that equals 90 degrees. So angle C and angle D are complementary. They just have to add to 90 degrees. Complementary angles. Okay, moving along. We talk about complementary angles. We have to talk about supplementary angles. All right, they are two angles whose measures have a sum, again adding together, of 180 degrees. So we just did 90 degrees with complementary. Now we're going to do 180 with supplementary. And each angle, instead of being called the complement, is now called the supplement of the other. So if you look right here, angle 3 and angle 4, they lie on a straight line. So together, if we add them, we know that those angles are 180 degrees. Over here, angle B and angle C. Again, not touching, but this is 43 and this is 37. When you add them together, you get 180 degrees. So you know that angle B and angle C are supplementary angles. Okay, and now to a linear pair. Linear pair is a pair of adjacent angles whose non-common sides are opposite rays. the angles of a linear pair form a straight angle, a straight line, 180 degrees. A linear pair, linear, think line. A line is 180 degrees. So here we go. We have angle ABD and angle DBC. They are a linear pair. They form a straight line, 180 degrees right here. That would be a linear pair. Two angles who form a straight line. All right, and we're going to talk about the linear pair postulate. If two angles form a linear pair, then they are supplementary. So if you see that it's two angles and they're forming a linear pair, a straight line, then they're supplementary. You can conclude that. All right, last one, angle bisector. Remember, we talked about a segment bisector where I humiliated myself and said, hi-ya, it's a ninja move. It cuts it directly in half. So again, hi-ya, we're cutting it directly in half. But this time, it's a ray that's being the ninja, a ray that divides an angle into two congruent angles. So right here, we have angle XAZ. Well, ray AY comes and slices through like a ninja and creates two congruent parts. So, because if this is an angle bisector, we're going to use this single arc and this single arc to show that these two angles are congruent. Angle XAY is congruent to angle ZAY. AY is the angle bisector of angle XAZ. Therefore, angle XAY is congruent to ZAY. And that's it for today, guys. Hope everything made sense. Please let me know if you have any questions. Bye.